Today we're going to review how to find a common base, like we looked at yesterday. We're going to start with the warm-up, solve for the variable. So if you notice, A, the base is 42 for both of them. And if they have the same base, you can ignore the base and look at the exponents. So if we do that, we have 2 times x minus 1 equals 50, and then we're going to solve. There's two ways to get rid of the 2. You can either divide each side by 2. A lot of students like to distribute, so let's show that. We have 2x minus 2 equals 50, and then we're going to solve for x. So we're going to add 2 to each side. We get 2x equals 52. We're going to divide each side by 2. So we get x equals 26. So if x is 26, then both exponents will be 50, and both sides of your equation will be equal. Take a look at b. This is like what we did yesterday when they don't have the same base. You want to make the bases match. So if we have 3 to the x plus 10 power, we want to change 9 so that it's also base 3. So I can rewrite that as 3 to the second power. 3 squared is 9. Don't forget about your x plus 1, so I'll put that in parentheses. All right, now that the bases match, let's set the exponents equal. So we have x plus 10 equals 2 times x plus 1, and now we can solve for x. So we'll have x plus 10. Let's distribute the 2. There's 2x plus 1, so this is 2x plus 2. Let's solve this for x. Let's get rid of the smaller x here. I'll subtract x from each side. I'll also get rid of this 2 right here. So we have 8 equals 1x, or 8 equals x. So here's our answer. If x is 8, both sides will be equal. And you can check your answer by plugging in and making sure both sides are equal. So to do that, we could do 3 to the 8 plus 10 power, or 3 to the 18th power. Does that equal 9 to the 8 plus 1 power? You could type each of these in your calculator, and if they were the same, you know that you did it correctly. Let's review just numbers of different bases so we can recognize them when we do some of the problems. All right, all of these numbers are base 2, so 2 to the first is 2, 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16. Remember, 2 times 4 is, or 2 to the fourth is not 2 times 4. It means 2 times 2 times 2 times 2 times 2. All right, base 3, we got 3, we have 9. 3 to the third power is 27. 3 to the fourth power is 81. Let's look at numbers base 4. Oops. 4 to the first is 4. 4 squared is 16. 4 to the third power is 64. 5 to the first is 5. 5 squared is 25. 5 to the third is 125. And again, remember what it means. It doesn't mean 5 times 3. It means 5 times 5 times 5. All right. So again, to review, if numbers have the same base, set the exponents equal. We get 3x equals 9 here. Divide by 3. X equals 3. This is a fraction. They both have base 3, so the x over 3, or x over 3 plus 5 is an exponent. So here's x plus 3 plus 5 equals 6. Let's solve. Let's subtract 5 from each side. We have x divided by 3 equals 1. How do we get rid of a divided by 3? We're going to multiply by 3. So again, here x is 3. So again, if they have the same base, you set the exponents equal, you solve for x. Here's what we did yesterday. If numbers don't have the same base, find a common base, rewrite and set them equal. So the first one, 2 to the x equals 32. So this is the same as 2 to the 5th power. And we know that x must be 5. All right, the next one, 16, I want to write that base 2. 16 is 2 to the 4th power equals 2 to the x plus 1. We have 4 equals x plus 1. Subtract 1 from each side. So we get 3 equals x, or x equals 3. Let's look at I and j. We have 3 to the x plus 3 equals 9 can be written as 3 squared to the x plus 1 power. So we have x plus 3 equals 2x plus 2 if we distribute. We'll solve here. We'll subtract x from each side. I'll also subtract 2 from each side here in the same step. 3 minus 2 is 1. 2x minus x is x. So we have x equals 1. Let's take a look at k, and then we're going to look at j. So for k, we have 5 to the x equals 25. Actually, we have to rewrite that, don't we? So that is 5 squared. But don't forget we have this extra 2 here. So let's use a different color. So we have x equals 4 for our answer if we look at the exponents. All right, the last one, j, 5 to the 3x minus 2. I want to write this as base 5, and we know that anything to the power of 0 is 1. So let's make it the same base 5 to the 0 power. So then we have 3x minus 2 equals 0. Let's solve. We'll add 2 to each side. We get 3x equals 2. Divide by 3. We get a fraction answer. What happens? X equals 2/3. So today you're going to practice finding a common base, and if it doesn't have a common base, you rewrite it, and then you can set the exponents equal and solve.